This work is part of the MFMET for establishing metrology standards in microfluidic devices, a European project financed by MPEER. My name is Elsa Batista. I'm the head of the Volume and Flow Laboratory of the Portuguese Institute for Quality, and I'm here to talk about the role of metrology and standardization in microfluidics. So first, I will speak about standardization. Standardization is the activity aimed at establish, in the face of real problems or potential, provisions for common use and repeated, with the view to obtaining the degree of optimal order in a given context. It consists in a particular way in the formulation, addition, and implementation of standards. And there is 6 very important aspects of the work of ISO and SAN, and they are transparency, openness, representativeness, impartiality and consensus, coherence, effectiveness, and relevance. And this is why standards are the common language of the world. Standards are technical documents. They are resulting from a consensus. They are approved by a recognized standardization body. For example, in Portugal, we have the Portuguese Institute for Quality. These documents are aiming at establishing rules, guidelines, or characterization of products and services based on consolidated results of science, technology, and experience, and that aims at optimizing the benefits for the community. How do we engage with standardization bodies and technical committees? At ISO and SAN level, first we need to find out which standardization technical committees and working groups could benefit from our work. Then we need to identify if your country is a participant or an observing member. We need to register as expert in the relevant technical committee working group. Check which relevant standards will be under review in the next years, and if a relevant standard is under discussion, try to send the comments and try to attend the meetings to defend the comments. ISO and SAN revision process. It's quite long. It takes up to 36 or 48 months to have a new standard available. Also, all standards are revised every 5 years. So how does the life cycle of a new or revised standard works? So first, we make a proposal. And this is a new work item proposal, and this is done by a P member. Then we have the preparation stage, where we develop a working draft, and this is done by the working group of a technical committee. Then we have the committee stage, where a committee draft is elaborated and sent to the technical committee for comments. The inquiry phase is where we have the draft international standards for vote and final comments. The approval stage, a final draft international standard is developed and is sent for vote for all the members. And finally, we have the publication of the document. And now I'm going to speak about metrology. Metrology is the science of measurement. And for this, we have 2 very important documents. The VIM, the International Vocabulary of Metrology, where all the important terms are described, and the GAM, the Guide to the Expression of Uncertainty Measurements, where information about uncertainty calculation is described in detail. And in these 2 documents, one very important term is disclosure. Traceability, which is the guarantee for quality of calibration results. And here on the right, you will see a traceability chain, a pyramid, where on the top we have the primary standards. For example, you see here a balance or the mass standard, and then on the bottom you have the device under test, which in this case will be a microfluidic chip. On the bottom of the pyramid you have higher uncertainties, and on the top you have lower uncertainties because we have the primary standards. Now, a calibration also gives us the error of a device and the uncertainty of that error, and also allow us to determine the accuracy of the device. But we can only do this if we have standardized calibration procedures that will lead us to comparable results. And for more information about metrology, you can go to euromet.org or the biapm.org website. Euromet is the European Association of National Metrology Institutes. It's a regional metrology organization of Europe, and it coordinates the cooperation of national metrology institutes of Europe in fields like metrology, traceability of measurements to the SI units, international recognition of the national measurement standards, and related calibration and measurement capabilities of its members. The science of measurement metrology is vital for scientific research, trade and industry, and our daily lives. EuroMet coordinates metrology research across Europe to provide the high accuracy, low uncertainty measurements that are needed now and in the future. 3 research programs are currently bringing together world-class measurement expertise in a series of targeted projects: EMRP, MPER, and EPM. More than 300 joint research programs have been completed so far. So, regarding metrology in microfluidics, where are we? We are developing harmonized documents in the form of white papers, guidelines, and standards for symbols and vocabulary, measuring quantities, interfaces and connectivity, modularity and sensor integration. And this is done within EuroMet, the Microfluidic Association, and the ISO group. We are also developing and characterizing standard chips to be used by the microfluidic community, and there has been several knowledge transfer to workshops in cooperation between EuroMet and the Microfluidic Association. One of the projects under the MP research program is the MFMET project, establishing metrology standards in microfluidic devices. This project was funded under the normative call of 2020. It has a 3-year duration and it started in June 2021 with IPQ as the coordinating organization. It has 17 partners from national metrology institutes to research institutions and companies. We have 37 collaborators and 1 chief stakeholder, the Microfluidic Association. This project aims to contribute to development of globally accepted standards for microfluidics and disseminate them to end users in industry, like health or pharmaceutical sectors, and also academia. And this is done by development of consensus-based measurement, protocols and guidelines, and also by the dissemination of metrology standards towards normative committee, industry and end users. What was done so far in terms of standardization in this project? We have worked with ISO TC48 Working Group 3, the microfluidic devices, in 3 different standards. The most important one, the microfluidic vocabulary standards, ISO 10991, that was published in 2023. We are currently working in ISO TS 6417, microfluidic pump symbols and performance communication, that is supposed to be published still this year. And also we have worked in the first document that was published by this working group, the interoperability requirements for dimensions, connection and initial device classification. Under ISO TC48 also, but under working group 5, we have worked in the automated liquid handling system documents, the 3 parts, and also the uncertainty of measurement procedure that was related to these parts of the standards. Under TC 84 Working Group 11 for syringes, we have worked in ISO 7886, the part 1 that is now under revision. And for the new SEN-SENELEC focus group standards for organ on chip, we have worked in the development of the standardization roadmap, especially in Working Group 1, which is related to terminology, and Working Group 3, which is related to engineering. Here you can find the microfluidic devices roadmap that was developed under ISO TC48 Working Group 3, and here you will see the timeline of work for 5 years, where we will be working on leakage, assemblage of microfluidic systems, wettability, sensor integration, quality control and characterization, and qualification of the microfluidic devices. And this work will be done with the harmonization of the work items from the SEN focus group on organ on chip. Here is our project team. You can find more information in the links in the video description, and on the project website mfmet.eu. Thank you very much for watching.